Alright, so on Friday, I want to make sure we kind of recap a little bit from Friday. We talked about a little bit about surface water, talked about runoff. We talked about the fact that streams have carrying capacity. And there were several things that factored into carrying capacity. Which one is probably the most important? Velocity. The faster the stream is moving, the more it can carry, correct? Okay? Now, there are two other factors besides just velocity. What were they?
Slope.
Slope. And slope is actually going to help you dictate your velocity, right? We saw that when we modeled that with the water that went all over the countertop. Steeper the slope, faster the water is moving. And there's a third one. And this is kind of important for you guys to understand. When we think about the temperature of the water, have you ever noticed that mountain streams tend to be very clear and they're cold? Okay? Not really too often do we see a muddy stream in Alaska.
Yeah.
Alright? They're usually clear. They're very cold. Yeah, take a look at the Amazon. What can you tell me about the differences in the water?
Wet.
Wet? Really? Wet? It's muddy. Okay, very good. But what can you tell me about the temperature then? Kind of. And the reason behind that, Cassie, the warmer water is, the more it can dissolve. Okay, for example, if you ever try to do dishes with cold water,
Yeah.
how'd that work out?
Sucks.
Yeah, you're going to spend twice as much time trying to scrub the food off the plate. Okay? But if you use warm water, what does warm water do?
Pick it off.
Literally just like dissolves the food away.
Yeah.
Okay? So again, actually, the warmer the water, the more it can dissolve. And so that's going to be one of those key characteristics. When we think about things that affect carrying capacity, velocity, slope, and temperature. The hotter the water, the more it can dissolve. So again, that kind of tells you why we have muddier rivers in warmer climates than we do in colder climates. Pretty much the same reason why you want to take a hot shower. That hot shower is actually going to help dissolve away all the sweat and the salt that your body exudes every single day. Okay, so that's another reason why we do hot showers. Now you're leaving my area of expertise and moving into the chemistry part of it.
Okay, then just don't say it.
Okay.
I'll live.
All right, so guys, I want you to take 2 minutes. And today we're talking about streams. We're going to do a lot of picture analysis. So I want you to compare the following two images. Make a list of compare and contrast. And take a moment and go ahead and just take 2 minutes and work with that with your partner. Give me some comparison and contrast here. What's the difference here?
One is flowing.
Raise your hand. Breathe.
The one on the right is kind of like calm.
All right, so we have calm waters versus.
The second one more like calm and like flowing faster.
So we got turbulent. So definitely we have a slow current versus rapid current. Okay, what else? Someone else. Kristen?
The one on the left has a lot of vegetation, and the other one is just rocks.
Okay. Tarita?
That one has like a V shape.
Ah, yes. Okay, so we have a V-shaped channel versus, what's the other one?
A stick. No, like it's like straight and.
So we have a wide channel over here.
Yeah.
Now, instead of a V-shape, maybe we can look at it and say a narrow channel. And where you are correct, it's like a valley. And this is basically how a lot of our valleys are formed, is from the incising of the stream. It's literally down cutting into the rock. What else do you guys notice? Tommy?
The first one has trees in it.
Yeah, so we got lots of vegetation over here, lots of rocks over here. Alexis?
Wouldn't the water be cooler on the left because it doesn't have any sun on it?
Yeah, probably gonna be slightly cooler. Maybe slightly warmer. Megan? Yeah, that's kind of what we're talking about here, right? Slow versus rapid, so we've got that. Rita?
That one kind of looks like it would like the river or something, like
Which one?
that one.
The one on the left has huge rocks?
Yeah, I kind of looks like it has rocks and
Like right through here?
Yeah.
I think that's mostly because of, well, we'll put it on there. I'm not sure we're gonna necessarily, actually what would be important to maybe mention here, large boulders that are still, right? They're not moving. Okay. What is this?
the one on the left, I think it would be like dirtier from the side of the grasses. Probably like sort of muddy and the one
So definitely more sediment. More sediment in the water or more sediment on the bottom? Yeah, I definitely say on the bottom, right? And why is that?
Because the other one's like flowing so fast that there's nothing that you can, it's already picked up all the sun in the bottom, and that one's just moving slow, so it makes sense.
Exactly. Remember, if we go back to carrying capacity, velocity plays a large role in your carrying capacity. Therefore, since this water's moving really fast, it's going to carry all that sediment downstream. Right here, we're going on a nice, easy little stroll, and all those sediments are going to filter out right here along the bank. Keep that nice and look. And if you go in there without shoes on, that's when you walk away and leaches. Those are always fun. All right, so I think we got a pretty good list here, and we're actually going to talk a lot about each type of these rivers today. And so we're going to constantly refer back to this over time. So again, remember yesterday, on Friday, we talked about the hose. And remember we talked about the fact that if you have a narrow channel, right? Narrow versus wide, it's the same thing as putting your thumb over the hose and you get this really fast, rapid moving river. But if you open up that channel, that river is able to move a lot slower and still have the same amount of discharge, because it has a wider channel for that water to flow through. So again, the wider our river, the slower it's going to move.